Hello everyone, welcome to this session. In this session, I am going to explain about the working of hydraulic motors. As I have discussed in the previous session, hydraulic actuators. Hydraulic actuator means which will produce the output power in the hydraulic system. The output power may be linear or it may be a rotary. If a output power is a linear movement, then we are going to call those actuators are as a hydraulic cylinders. If the output power is a rotary motion, then those actuators we are going to call as a hydraulic motors. And hydraulic motors of different types. Those may be gear motor or vane motor and piston motors like that. And I'm going to discuss all these types of the motors in detail. At the end, we'll come to know the applications of these motors in the hydraulic system also. Here first I'll take the gear motor. The rotary actuators converts energy of pressurized fluid into rotary motion. Rotary actuators are similar to electric motors but are run on hydraulic or pneumatic power. Okay, it is about the rotary actuator, and this rotary actuator we are going to call as a motors. Then gear motor consists of two intermeshing gears. Inside a housing, one gear is attached to the drive shaft. It consists of two gears. Okay, these two are the two gears which are intermeshing, and one of this one gear is connected to a drive shaft. Of the shaft gear is connected to drive shaft. Then here the fluid enters from the inlet. The fluid enters from the inlet, causes the rotation of the meshing gear. Here the fluid inlet inner at the inlet and causes the rotation of these gears. That means here when it enters and that will be pressurizes on this the gear teeth. The pressure will be applied on both sides of the gears, and due to that the rotation of this gears will be taking place, and the fluid inlet in at a higher pressure it will be taking place, and here the fluid will be carried between the teeth, okay, during its rotation with a pressurizer, and the spur gears are used for the this gear motors. And here the fluid at a low pressure it will be coming, low pressure it will be coming out, okay, because there the pressure energy will be converted into mechanical rotary power. Low pressure fluid will be going out from the actuator. Then the fluid exit from the exhaust port. The fluid will be exit from the exhaust port. Gear motors tend to leak at low speed, hence generally used for a medium speed applications. These gear teeths are gear motors which are usually leak at a lower speeds. Whatever this oil is carrying around this gear teeths and the housing, whatever is there, and between that there may be minute gap, and between the teeths of the gears also there may be minute gap. Through that the leakage will be taking place at a lower speed, and therefore it will be used for the medium speed only, not lower speeds gear motors are used. Moving to next, a vane motor. Vane motor consists of rotor with sliding vanes in the slots provided on the rotor. Okay, it consists of rotor. This is a rotor and slots provided in the rotor in which the vanes are sliding. Vanes are slides inside that one during its rotation. The rotor is placed eccentrically with the housing. This rotor is not concentric with this housing. The outside housing or casing is there, and inside rotor is somewhat eccentric. Its center is different from that of the center of the this casing, and that we are going to call as eccentric. And this eccentricity already we have discussed while discussing the vane pump. Okay, then that also we can refer here what is the eccentricity and what it causes. The eccentricity is the maximum fluid flow will be taking place. Therefore, that will causes the more rotation of the this vane motor. Fluid enters from the inlet port. The fluid enters from the inlet port, then rotates the rotor. That will rotates the rotor, and thus torque is produced. The torque is produced, which is connected to the drive shaft. Fluid is then released from the exhaust port. From the exhaust port, the fluid is released in the rotor. By this, we are going to get the rotary motion from this vane motor also. Going to the next, this is also rotary actuator, but it is a limited rotation rotary actuator. Limited rotation means about swinging, we will call as a swinging. Okay, for the particular angle. For the particular angle, how the swinging it will be taking place, that we can take here. It consists of a single rotating vane. Okay, here we can see this is a single rotating vane. There is a movable vane connected to output shaft. This will be connected to a output shaft. It is used for the double acting operation and has been maximum angle of rotation about 270 degree. Okay, here double acting means in this direction also it will rotate. Here the angle we have shown both side. That means in this direction also it will rotate, and other direction there is a clockwise and anti-clockwise it will rotate. When the fluid enters through this port, there are two ports, then the rotation we are going to get in this direction. If the fluid enters in the other port, we are going to get the rotation in the anti-clockwise direction. Like this vane will be swings inside. Therefore, the whatever the shaft connected to that, it also swings at particular angle. The rotation for the particular angle will be taking place. Maximum angle is mentioned 270 degree. These are generally used to actuate dampers in the robotics. Used to dampers. Damping means it is a particular angle, it oscillates. Okay, that in the robotics we are going to use. And material handling applications. Other types of limited rotation actuators is a rack and pinion type of the actuator. Rack and pinion. Okay, which will be moving at a particular distance. Okay, rack and pinion. Okay, that will be swinging one uh, in the particular distance only, and that swinging will be by using the rack and pinion type actuator we are going to take. Same will be here. This is the rotary rotating vane which is connected to shaft, and this is a stationary barrier. Up to this one it will rotate for the one direction and again come back and goes and rotate up to this fixed barrier. Thus the shaft will be rotates for that angle. Okay. This is about the limited rotation rotator we can call, which is swings or actuates oscillates for the particular angle of rotation. Moving to the next, piston motors. And in that piston motors, first I'll take that is a swash plate type piston motor. In variable displacement units, the swash plate is mounted on the swinging yoke. The variable displacement, this is the swash plate which will be mounted on the swinging wake. That means this angle, whatever is there with the horizontal, that can be changed. That angle will be changed. Okay, for the displacement not to vary. As the angle changes, the piston stroke will be varies. This piston stroke will be varied. By that one, the speed will be changed. The angle can be varied by various means such as lever, handle, wheel, or a servo control. This angle of this swash plate can be varied by any means of this. If the offset angle is increased, this offset angle is increased, makes a horizontal. The displacement and torque capacity increases. The displacement and torque capacity will be increases. But the speed of the drive shaft decreases. The speed of the drive shaft will be decreases if the angle is larger. Conversely, reducing the angle reduces the torque capability. Angle if you reduce the torque capability it will be reduces, but increases the shaft speed. Okay, the shaft speed it will be increases. Here the pistons will be reciprocates inside, okay, during the flow of the fluid, and thereby rotation of the shaft we are going to get in the piston motor. That is of the swash plate type piston motor. Next one, bent axis piston motor. A bent axis piston motor develops torque due to pressure acting on the reciprocating piston. Okay, the pressure acting on the reciprocating piston, it will develop a torque. In this motor, the cylinder block and the drive shaft mount at an angle to each other. That force the piston is exerted on the drive shaft flange. Okay, here the piston and this is the drive shaft, which are at an angle. Which are at an angle. This is the direction if you take. This is the angle. Okay, the axis of the driving shaft and the piston are bent, and that's why it is called as a bent axis. Okay, then speed and torque depend on the angle between the block and the drive shaft. Okay, the speed will be depending upon that speed and torque depending upon this angle. This angle can be varied by varying the that flow rate as well as the torque and speed we can change. The larger the angle, the greater the displacement and torque. If the angle is large, the greater the displacement and torque, and the smaller the speed. The speed will be reduces. This angle varies from 7.5 degree minimum to the 30-degree maximum. Okay, this angle is 7.5 to 30 degree. This angle, this much it will be varies minimum to the maximum. This type of motor is available in two types, namely fixed displacement type and the variable displacement type. That means if you change the angle, if you want to possible to vary the angle, then the variable displacement type we are going to get. And if it is a fixed displacement, the speed and torque we are going to get from it. And two types of this bent axis piston motors also we can pick. Then last one in the piston motors, radial piston motor. In radial piston motors, the piston reciprocates radially or perpendicular to the axis of the output shaft. Okay, here the output shaft, whatever is there in that perpendicular to that one. If its axis is this one, the perpendicular to that, the piston will be reciprocates, and radially these are reciprocates. The basic principle of operation of radial piston motors is shown in figure. The basic principle of operation, this one. You can see here the pistons which are reciprocating inside, and fluid is enters here, and due to its force, the it force to rotate the this inside rotor, and that thereby the piston will be reciprocates. And here also there is a eccentricity. There is a eccentricity between the this outside uh, casing as well as the inside rotor. And here this is cylinder block center line as well as the reacting ring, outside reaction ring. We can call the below the casing the layer which is there, that we are going to call as the reaction ring. And here the pintle which will be at the connected all the flow of the pistons at the inlet and the outlet, those are called as the pintles and piston. And here is the inlet and outlet we are going to get from it. Cylinder block, okay, then reciprocating the reaction ring, it is the reaction ring which is supporting to the that pistons, and thereby due to the fluid pressure these pistons reciprocates and cause to rotate the shaft. Radial piston motors are low speed, high torque motors. Speed will be low, but the torque producing twisting moment or the power what we are going to get in the form of rotation, which will be more, which can address the multifarious problem in diverse power transfer applications. Okay, it is a various the to solve the problems to get the higher power, and there we are going to use this type of the radial piston motors, and their animations with the working I'm going to take in the further sessions, and you can watch those videos also in order to get that is how the actual working with the animation is taking place. Thanks for watching. If you like, share, subscribe and comment.